I'm going to just spend a quick 10 minutes going through Materialize, some of the challenges that we solve, and then obviously we want to reserve a majority of the time today for Josh to go through the technical demo. So just to start, a little bit about Materialize, us as a company. So we were founded in 2019. We're headquartered in New York. Arjun and Nikhil are a couple of our co-founders, along with Frank McSherry. They have a vast amount of experience in the data warehousing space. Frank McSherry is the author of Timely and Differential Data Flow, which are some of the core components of the Materialize platform. Outside of that, we've got a host of folks that have very, very deep understanding of both the data warehouse space and streaming in particular. So we've got a couple of committers around the Flink project working for Materialize. So definitely a heavy technical team that understands a lot of the concepts that we're going to walk through in the deck at a very, very low level. We've raised $100 million thus far from some of the top tier Silicon Valley VCs, such as Lightspeed, Kleiner Perkins, and Redpoint. And we've been able to get a tremendous amount of customers. So we're not going to go through a lot of customer use cases today. I'll try to weave some in as we go along. We've got a great customer reference page on our website if you want to get any more information on some of the logos that we're working with. But General Mills, for example, which is a great one, you've probably consumed in some way, shape, or form one of their food brands. They're using Materialize to input IoT data coming from their manufacturing devices to better understand food waste and obviously mitigate that, because food waste is money out of their pocket. But again, we've got a ton of other customers that are out there, and I'd highly suggest that if you're interested in learning more about the use cases, that you head over to our website and consume some of those materials. So let's take a little bit of a step back and, Materialize first and foremost, we're an operational data warehouse. You probably understand what a data warehouse is. That's a concept that's been around for a very, very long time. You're probably getting images of Oracle, Snowflake, BigQuery, Postgres. There's a lot of different flavors of data warehouse that are out there. Operational might be a term that's somewhat new to you, and we feel that it's probably good to take a step back and define what we mean as operational, which we'll walk through on the next two slides. So we basically view the world in two different data workloads. One is an analytical data workload. The other is an operational data workload. So analytical is one that you're probably familiar with. We consider that more historical analytics, ad hoc analytics. So think about if you had the last 3 weeks of sales data, you would batch that into something like a Snowflake or a BigQuery or whatever data warehouse flavor that you're using. You'd use your Tableau dashboard and you'd ask some questions of it, right? It's generally the way that we look at it is things that have happened in the past. But what we find is that folks want to interact with the data as it's happening, which we define as an operational data workload. So Ramp, one of the customer logos that I shared on the last slide, they are currently using Materialize to look at account takeovers. So if you're not familiar with an account takeover, that's essentially a fraud use case where you have a bad actor that is taking over a customer account and making a bunch of charges that obviously shouldn't be taking place. And the more that you let an account takeover happen, the more that you're losing money, both from the consumer standpoint as well as the organization who has to mitigate those losses. So it is imperative that you act on the data as it's happening. And that's an example of an operational data workload. But to peel back the onion even further, what we define as an operational workload is really three key pillars: freshness, responsiveness, and consistency. Right. So, real time, that's a term that's used in a lot of different, it's been used by vendors in a lot of different ways. So if you were to Google real time, you'd probably find 100 different vendors that have different definitions of this. So for our definition of real time, it's, are you acting on the freshest data possible, as in that data that's coming in, you're able to act on it. So in the Ramp use case, again, you're able to see what's going on. It's not an hour going by or 2 hours going by. You're able to, within milliseconds, understand what's happening. Responsiveness. So from a responsiveness standpoint, a query standpoint, you're able to ask questions of that data as it's happening. And from a consistency standpoint, so consistency might be something that's not too familiar, but there are systems out there that are not consistent, right? But in that Ramp example, you have to understand, you have to be consistent with that. It can't be eventually consistent like we find with some other systems out there. And again, these are kind of the three pillars that we feel define a real-time workload that Materialize can deliver on. And there's systems out there. Operational workloads have been out there for quite some time. So what we've typically found as ways that organizations have tried to address these operational workloads is really two streams of thought. One is your traditional cloud data warehouse. Again, the Snowflakes of the world, the BigQueries of the world, things like that. And those are really easy to use. They use SQL as well, which is a very common programming language. But the problem is that they're batch-based systems, right? So when you get to these real-time workloads, you're having to constantly refresh the system, right? That balloons a lot of compute. It generally becomes really expensive, really quick to host these operational workloads in a system like that. And operationally, it can be very, very complex to keep these systems up and getting to the latencies that you're looking for. And at the end of the day, what we hear from most of our customers and prospective users is that you really can't get the time to insight that you want. You can only get, you can only get data that's so fresh with a system like a traditional cloud data warehouse. On the other side of the house, there's concepts of stream processors and microservices. So stream processors, you can think of Spark or Flink, are very popular open source stream processors. And, these might be able to deliver on, data freshness, right? But they're generally very, very complex. And what we've found is that your typical BI or analyst that wants to interact with the data, they generally can't, right? It takes, a very, very intricate skill set, or developed skill set, I should say, to interact with these tools. And operationally, they can become very complex, right? So, when you look at the infrastructure that's behind hosting something like a Flink or a Spark, it can get very complicated very quick. So that really brings us to Materialize, and some of the benefits behind our platform is we really want to marry the best of both worlds, right? We've got a powerful stream processor under the hood, which is timely and differential data flow. But we abstract that by being PostgreSQL compatible. And that's really the key thing here, is that you don't need to be a deep streaming expert to use Materialize. All you need to know is SQL. And because we're PostgreSQL compatible, you can bring whatever BI tool or data science tool that is compatible with PostgreSQL as well. We are a SaaS service, so we're completely hosted. You don't have to worry about hosting any of the infrastructure. We take care of all of that for you. And again, that's really the benefit that we see with Materialize, is we're marrying that power of stream processors with the ease of use of a cloud data warehouse, and being able to do everything in SQL. So just quickly going through the architecture so you can start picturing in your head where Materialize would fit in your data landscape. So we don't replace data warehouses, right? If you want to run ad hoc workloads, you still want to run those historical workloads that I mentioned on the first part of the slide. That's definitely something that you can do. We have a lot of customers that are still using something like a Snowflake, a Postgres, or a BigQuery alongside of a Materialize, because again, I think what we're finding is it's the right tool for the right job in the data landscape. And it's usually not one tool that can solve everything, right? But over here, so Materialize has a lot of sources and sinks. We support webhook sources. We support Kafka. So that might be getting the data into Materialize. And then again, we have customers that have Power BI dashboards, that have Looker dashboards, that are actually building applications and using our APIs to query the data that's in Materialize. And then for some of those, maybe more historical workloads, we can still send that data to something like a Postgres or a Snowflake or something like that. So again, just kind of giving some context on where we would fit in your ecosystem. And the last slide that I'll present is this peels back the onion on what's underneath the Materialize service. So as you can see here, as I mentioned on the last slide, we can support a lot of different sources and sinks. So you can get that data, and we use S3 as a persistent data store. So your data store would be that. It's a separation of storage and compute, which has really become an industry standard to make sure that you're running these data workloads as cost effectively as possible. The compute right here, this is where timely and differential data flow really does its magic. And again, the way that you're interacting with everything is just via SQL. So, that Postgres SQL compatibility, it really makes it easy to get started. It makes it easy if you do have, so we have a lot of customers that have workloads already in some type of data warehouse, and they have to refactor very, very little SQL, if nothing at all, to get started with Materialize, which again is a big win, so that you're not having to do a bunch of refactoring to use another technology. And again, when it comes to any sort of BI tool, data science tool, however you want to interact with our service, it should be completely easy. So thank you. I'll pass it over to Josh. I'd highly suggest that, if you are interested in giving Materialize a spin, we have a playground environment as well as trials. And as I mentioned, if you want to dive into any of the customer use cases a little bit deeper, feel free to go through the our customer page on our website. But yeah, I'll stop sharing and hand it over to Josh.
That was really good sort of overview of Materialize. What I'd like to do today is just give you a little demo and show you how things work a little bit. In particular, I think we often fall into thinking about real-time data and Materialize in particular as this big overhaul of our data landscape. And we've done a lot of projects with people where we go in and do big, complex workloads, a big move into real time. I think what I'd like to highlight today is that Materialize can be a really great tool when you just have a few real-time needs, and it can actually be a terrific way to very quickly and easily get up and running, for some of the smaller workloads that maybe in the past didn't even think that real-time or operational workloads were a possibility, right? So for the use case today, I'd like to imagine that we are managers for a chain of 3 retail stores. And here's our use case. We found that it would be really impactful to be able to compare our incoming revenue for the day over the course of the day as it's happening, with the average of weekdays for the last 2 weeks, right? So simple use case for monitoring how we're performing throughout the day. And we can respond immediately if one of our stores is trending badly for some reason. We can diagnose the problem. And we're going to achieve this with 2 SQL queries and a simple dashboard visualization. In addition to that, we may want to implement we want to implement an alert if one of our stores stops booking revenue for a period of time, since it would indicate something going very wrong at that store that we'd want to be alerted about, even if we don't happen to be looking at the dashboard at that time. So 2 use cases, right? Real-time visualization and alerting. We're going to prepare our Postgres database for replication, right? Then we're going to use the Materialize console to create a connection to the database. We're going to use a Materialize source for syncing data from Postgres into Materialize. We're going to use a SQL editor to build Materialize views to generate our data. And then we're going to use a SQL editor to create indexes on top of our data so Materialize can keep them up to date and update them continuously. We're going to create a visualization in Grafana to view the data, and then we're going to subscribe to a view in Materialize for our alerting. And we're going to do all of this in about 20 minutes. So let me, at this point, share my screen, and so we can start building this. All right, can everybody see that? Okay, great. Yeah, so this is our front page. This is the Materialize console, and you can see as of recently, it takes you right into the SQL shell. So the nice thing about this is you don't have to worry about any connection parameters or anything like that. This will be where we do most of our work today. But before we do that, we have one administrative task to take care of, and we're going to see just how easy this is, right? We have a Postgres database. So here, I'm going to open up a pSQL shell to Postgres. And the first thing I'm going to do is set up my 2 tables for replication. If you've ever set up a Postgres replica, you've done this before. set up my tables for replication, and then create a publication called Materialize, right? To replicate these two tables, sales and store. And we're done. Like the rest of this happens in Materialize. Our database is now creating a replica, and the way that we will consume the data in Materialize, basically we are capturing changes from the database. So anytime there's a create, update, or delete in any of these three tables, it's going to replicate into the Materialize backend, be written durably to our storage layer, and also be available to all of your compute clusters in Materialize for doing work in real time.
Hey, Josh.
Yeah, go ahead.
Well, just FYI, only your Materialize console is showing. I don't know if you were trying to show the SQL in Postgres, but you're only sharing the window for the.
Let me double check that.
Thanks, Bobby.
Window. Entire screen. That's the one. Okay, should be better off now. Okay, so I'll just show you real quick what the screen looked like. Two commands, right? Turn on replica identity full for the two tables and create the publication. That's all the configuration that has to be done in Postgres. And all right, so the rest of this is, we're going to be in Materialize and Grafana. So the first thing we need to do is tell Materialize how to connect to our database, right? So that it can have this real-time connection to the write-ahead log on the database and see the changes as they're happening. So the first thing I'm going to do is, well, actually, we're going to do one step first. We're going to create a schema called Postgres, and we're going to create a cluster called Compute. And we're going to say, we're going to give this the smallest size. A cluster is basically how we, it's like a warehouse in Snowflake. It's where all of our compute comes from. So we have a dedicated cluster now for our work. And this is a good pattern in Materialize for development. We can spin up clusters at will, do a little development and Materialize, and then throw them away. It means we don't have to pay for, development capacity. People even do this in staging sometimes. Anyway, so we're ready to work now. The next thing we're going to do is we're going to create our connection to the database. So I'm going to come here to the Connections tab, New Connection, select Postgres, and I'm just going to call it Postgres Connection because I'm not creative. And we're going to put it into our Postgres schema that we just created. That schemas are free. It's just, where the objects live in the database. Very much like, you'll notice a pattern. Things look a lot like Postgres in here. That's not a coincidence. We try very much to replicate the experience of Postgres and be Postgres compatible, both in our wire protocol and in our query language. So we're going to put it in the Postgres schema. This is the host of our database. We're running on RDS, but you can really run the database anywhere. It doesn't matter. Our database, if you remember, is called Materialize, standard Postgres port. We use the standard Postgres user, although you probably want to create a dedicated user for Materialize. We can store passwords in our cloud securely, so you can create a new secret if you want to put it in. I've already created my password here, so I'm just going to select that. And for SSL mode, we'll verify the CA, we'll require it for this, and create our connection. Now, this is not consuming any data yet. All we've done is told Materialize where our database is. In order to actually consume data, we'll do this next step, which is to create a source. And what creating a source does is actually stands up a process in the Materialize cloud that is going to sit there and watch the wall log on the database, in this case, or your Kafka topic or your webhooks, and persist those data into the backend. It's a separate component so that it's not, it's completely decoupled from your compute workloads. So I'm going to create a source. You see it's automatically pre-populated my connection information for me here. And I'm going to call this Postgres source. Again, we'll put this in my Postgres schema. Here is this compute cluster, remember, that we created. And we are going to, remember when we created the publication on the Postgres side, we called it Materialize. So we'll, and then we'll put in our tables. So we had sales and we had store. And click on create source here. And then that's it. That's the whole process. So you see now my source has been successfully created, and you see how it just flipped to running. That means the component has been stood up on the back end, and now it's beginning to consume data. So we'll actually be able to see any errors that occur in here. You'll be able to see all kinds of details about our source from this tab. But we're actually ready to start working with data now. We're as this data updates on the back end, let's go to our SQL shell and start building some analytics. So if you remember, we said we wanted to compare today's sales, right? Today's cumulative sales to the average over 2 weeks. So in order to do that, we're going to have two main SQL queries, one for our daily average and one for our 2 week average. We'll put a SQL query over both of those at the end to combine the data, and then that's what we'll use in Grafana. So let's do the first query here. First thing we want to do is set our session so that we're using the compute cluster and the Postgres schema. You can also set those from up here, actually, and you'll see those just updated. And then the next thing that I want to do, this is going to mean, this is by setting those parameters, that's where my queries are going to live, is under those, under that cluster and under that schema. So here's my first query. One thing that you'll notice first about the Materialize syntax, it looks very familiar if you've worked in Postgres at all. This is not a coincidence. We work very hard to maintain Postgres compatibility. You know, it is possible to find some Postgres functions that we don't support yet, but like for the most part, if you can write it in Postgres, you can usually write it in Materialize. So for our query, we have a CTE, which is just extracting the hour and the minute from our data, getting the total revenue, right, for that minute timestamp. And then you can see we're grouping by store ID, hour, and minute from this table. So basically just getting 1 minute data. You'll notice this filter here, which is our time filter. This is where we tell it we only want a day's worth of data, and it's a moving window. And then outside of the CTE, we're joining it to itself. And the reason that we're doing that is so that we can have cumulative data, right? We don't want to see individual 1 minute timestamps. We want a graph that rises as the revenue accumulates over the course of the day. So we're taking each timestamp and adding it to the previous one, right? So that's what we're doing here. It's nice to highlight the fact that Materialize has very capable joins. This is a superpower of Materialize. If you've ever worked in any other streaming frameworks or tools, like there's usually very limited support for joins. Maybe you can only do a two-way join, or maybe there's limited join semantics. Materialize is very good at joins, and it's very good at correct joins. So it will make sure not only that I've seen 30-way multi-way joins done in Materialize, and you can do it, and it will never produce incorrect results. In other words, it will wait until the data across all the joins is present for a particular timestamp, so that we guarantee correctness. Super important detail with the streaming system that I think many people don't even think of until they've been working in streaming for a while. Okay, so that's all it takes to create a view. This view isn't doing anything yet. It's just stored as SQL within our schema. But we want this view to run all the time and be kept up to date as our data changes. So we're going to introduce the concept of an index. An index in Materialize, not quite the same as in a static relational database. Similar concept, right? The idea here is to keep up-to-date access of the data, but this is actually going to tell Materialize, hey, we want to run this query all the time, keep it up to date, and we want fast path access by these three fields. So in other words, I want to be able to put the store ID, the hour, and the minute in a where clause and have point lookups on those. But it's going to store the full data of the records in the index. So this is where we're consuming compute, we're consuming RAM first and foremost, because we're standing up something in memory to maintain this so that as records change upstream, right, it will change our index. So that's all I need to do to create an index on this view. It's going to now chew through our back data. Remember, this is a one-day window, so it's chewing through the full day's worth of data right now. And once that's done, it will continue to run as new data comes in and push the deltas. So let's move on to our second query, and then we'll take a look at this. Second query looks a lot like the first. The inner CTE, again, pulling 1 minute samples. Now here, our where clause is a little different because we're looking just at weekdays here, and we're doing 14-day average. So, a 14-day interval rather than a 1-day interval. Here, this outer CTE, again, we're joining it to itself so that it's cumulative. And then we have sort of one more layer in this one, because what we end up with is 14 one-day averages. And what we actually want is an average of the 14 days. So we'll average all the 14 days in the outer layer. And okay, that's our 14-day averaged view. And now I'm going to create an index over that, over the same three fields, store ID, hour, and minute, so that we have fast access to those data points. And then the last thing we're going to do, and then we're going to move to, then we're going to be done writing queries. We're going to create a combined view. I basically want to be able to plot these two graphs across the same axes. So I'm going to join these together by their timestamp. So that's what this view is doing. It's taking the data from the average view, the average cumulative, it's going to take the today view and the weekday average view and combine them on the same axes. And then we'll create an index on that just by store ID. This is what we're going to use to graph. So we'll be able to ask for a store, give me the data points. And all right, that's it. We're done. We've created 3 indices and 3 queries. Now let's build a real-time graph on top of these. So to do that, I'm just going to use Grafana Cloud. You can really use, like I said, the cool thing about Materialize is Postgres wire compatible. So most tools that support Postgres support Materialize just fine. I'm using Grafana because it's super easy to get started with, but you can use really any BI tool. People use all sorts of different tools, but Metabase is a popular choice for this. Also Tableau. So we see a lot of different things. So I'm going to create a new dashboard here. For my data source, I've pre-created it, but let me show you where, if you want to create a data source, all your connection info lives right here. External connection info from this external tools tab, and you can copy and paste it in. So I've already done that here. So we're going to use, notice it's just using the regular Postgres adapter. It's not using a special Materialize adapter to underscore the compatibility there. So let's build our first graph here. This is the query. Now, one thing you're going to notice about this is that I am pulling, so we're going to have this refresh once a minute. Or we'll have it refresh every 5 seconds, actually. And one thing that you would normally consider bad practice over top of a database, we're pulling the entire data set every 5 seconds. This would be really tragic to do in a lot of databases that need to recompute every time you run the query. But because we've stood up these indexes and all this data has been pre-computed, pulling the full data set every 5 seconds here, it's just a cache hit. So all the data is pre-computed, and we're going to get, in usually double-digit milliseconds it's going to return with the answer. So let's go ahead and put this query in. You can see how quickly that came up. We'll call this, let's call this store one, and we'll apply it. Make this a little bigger here. There's our store one graph. We've got 3 stores, so let me duplicate this, go in and edit this one. We'll call it store 2, and in our where clause, we'll just put store 2. Apply that, and then we'll edit the third one, make it store 3, apply. I'm going to, let's look at the last hour. Okay, so as promised, we have real-time data for our 3 stores. Let's do a quick analysis here. Look, for store 1, the yellow line is today's revenue. The green line is the average revenue. So we're slightly underperforming, but pretty close to average today for store 1. Store 2 is definitely doing the best. It's overperforming the average by a pretty good margin here. And by the way, I always do this. Let's change this to 5 seconds so we can see how quickly our data is refreshing. And you'll see every 5 seconds. Well, these are 1-minute data points, so every 1 minute we'll get a new data point on here, but we could refresh more frequently. And then our third store looks like, it's pretty close to the first store, maybe doing a little bit better. Anyway, so there's our, so we've just created real-time visualizations in just a few minutes over top of our Postgres transactional database. Now, I promised one more thing, which is alerting. So we're done with the visualization portion. Let's go build an alert. I'm going to come back to my Materialize console here. Let me go back to the SQL shell, confirm that I'm in the compute cluster, and I want to be in the Postgres schema here. And so for this, we're going to build this view over top of our sales data. And what I want to do is say, build a view just for the last 15 seconds worth of data. So this is going to give me all the sales records where the created at column is within the last 15 seconds. And as usual, we're going to stand up an index on top of this, indexed by store ID, that's going to keep it up to date. So now this index is going to show us all the sales from the last 15 seconds. Now, rather than just write a stat, I can write select queries against this view, right, and get the answer back, and I could poll it. But let's do something. I want to highlight a really interesting feature of Materialize called subscribe. What subscribe does is this will give us the ability to run a long-lived Postgres query to our view, so that this is going to keep an open connection to Materialize and consume the updates as they happen. So here in our console, we can see it. You see how the count is changing? This is telling us how many records we've seen in the last 15 seconds for store ID 1. And you'll notice it just takes a regular select query and subscribes to it. So this is pretty cool. And like when, we can build an alerting system off the back end of this. And basically, if the count ever goes to 0, hey, that's an alert, right? We haven't had a sale for 15 seconds. So you can think of, we use subscribe to make Materialize part of event-driven chains all the time. So Materialize doesn't just have to be the end of an event-driven model. Materialize can be a link in that chain that's pushing events downstream as these analytics change, as these Materialize views change. You can consume them downstream this way. And let's just really quickly show that this is working. I'm going to log in here and turn off the data gen service and go back here, and we'll see our count start to decrement as there's no new records in the last 15 seconds. And by the end of about 15 seconds, we should see this go to 0, which it does, right? So this indicates something's wrong with our store. We're in alert condition now. And if I go back here and restart my data on the back end, we'll see the count starts to increment right away. So that shows you sort of how Materialize can be a great solution for downstream event-driven real-time systems, alerting, that sort of thing. And that was the last thing I wanted to demo today. I hope that we've done a good job of showing sort of how quickly you can get operational and build some real-time visualization, some real-time streaming systems with Materialize using just the knowledge that your data analyst team might have, same set of knowledge that they would use to work with a data warehouse. And that's it for me. Thanks.